moving on to a very interesting topic in coordinate geometry, and the first one that people want to study because we are so familiar with it, and this is circles. So we'll start right away.
Yeah, like we'll study from the basic equations of the circle.
Okay.
So the equation of the circle with the center h comma k and radius I is given by the equation x minus h whole square plus y minus k whole square equals to r square.
Right.
So it should be the r square.
Right. Because the radius is obviously non-zero.
Yeah, it's a small typo error, sorry.
Okay.
But next, the equation x square plus y square equals to 2gx plus 2fy plus c equals to 0 always represents a circle whose center is minus g comma minus f and radius is root over g square plus f square minus c.
Okay.
And it is denoted by s.
Okay, an interesting thing again to note here is we have the condition, we are so confidently able to say that it'll always represent a circle because there is no xy term there.
Yes.
Right.
Now, if the circle intersects the x-axis at two different points,
Okay.
the x-intercept is given by 2 root of g square minus c and y by 2 root of f square minus c.
Huh.
Like you might be then what happens if it does not intersect the x-axis? The g
Okay.
square minus c will be negative.
Right.
So we'll take the intercept as 0.
Okay, actually I'd like to stop you there, and we have this formula for radius to be root over g square plus f square minus c.
Yes.
Now this is a term under the square.
Yes.
So what if it is negative?
Means in the radius term.
Yeah.
Then if the radius is negative, it means that the circle does not exist. It's an
Right.
imaginary circle.
So again, that is a condition. So a circle can only exist if this condition is satisfied that g square plus
Plus
f
f
square
square
has to be greater than c.
yes.
Correct.
So if you want, you can add a condition here: g square plus f square greater than c.
Right.
Now the position of a point. First we define S11 as we substitute what we might be thinking what is S11. Like S11 is given by the formula x1 square plus y1. We're just replacing the S11, the point x1 y1 in the given equation.
Right. And in coordinate geometry, the letter S, capital S, is usually used to represent a circle.
Yes.
Okay.
So S11 greater than 0 indicates the point is outside the circle. Equal to 0 usually indicates on the circle.
Right.
Less than 0 indicates
On the circumference, in fact.
yeah, on the circumference of the circle.
Okay.
And less than 0 indicates the inside circle.
Right.
Like usually in each and every chapter we represent that conics equation by S.
Okay.
Like in circles S will represent the ellipse
okay.
equation.
Right.
Like that. Oh. Now like if you take a point outside P, so if you want to calculate the least and maximum distance of a point from any point on the circle,
Right.
then the minimum distance is given by root of modulus of Cp minus R
Right.
and maximum distance is modulus of Cp plus R. You want to be thinking how? Like just draw a circle like this. If this is the P,
Okay.
now we'll draw
Okay. So the minimum distance will obviously be.
the Cp minus this distance, which
Right.
is R. Maximum distance will. We're doing y like this only.
Okay.
So we'll draw like this.
Okay.
Then what will be the condition? Then again we'll have to put the Pythagoras theorem. Find
Right.
this
So we
distance.
can easily show that this will be the minimum, and the diametrically opposite point will be the maximum
Yes.
distance. Okay.
Now the equation of circle in parametric form.
Right.
Like let us assume a point P x comma y any point on the circle.
Okay.
X square plus y square equals to r square. Now we are taking another circle equation
Right.
whose center is 0 comma 0 and
Uh-huh.
radius is r. This is actually the standard equation of circle.
Right.
And OP makes an angle theta at the positive x-axis.
Okay.
And let us assume modulus of OP equals to r.
Yeah, in fact, you can, turn in any equation of a circle into this form by just shifting origin.
Yes.
Right. So if you have a circle whose center is at hk, you can just transfer the origin to hk, and then you will get a circle equation of the form x square plus y square is equal to r square.
Let's assume the circle. 0 is the origin. This is the circle.
Okay.
So this is the distance and angle theta.
Mhm.
So the point coordinates are given by x equals to r cos theta and y equals to r sin theta.
Right.
It's a parametric form of the circle. Like now, let us assume the intersection of a line and a circle. This is not a point; it's a line.
Right.
So this is a circle. This is a line. Its equation is given as y equals to mx plus c.
Right.
And its equation is given as x square plus y square equals to r square. So
Okay.
what we do is we just substitute the value of y of the line in the circle
Uh-huh.
because if we assume that the line intersects the circle,
Yeah.
Then
So it
the-
has to satisfy this condition.
both it
Right.
satisfy the both. So if we substitute, there will be no change.
Okay.
So after substituting and rearranging,
Yeah.
we'll get the equation as x square into root 1 plus m square plus 2mcx plus c square minus r square.
Okay.
If we carefully assume it's a quadratic if we carefully see, it's a quadratic in x.
Right.
So if it has real and distinct roots, then x will have two different values.
Correct.
And from the quadratic equation, that condition is d
Right.
is greater than
And
0.
visually the what you can conclude from this is that if the first condition is satisfied, it will have two distinct real roots. That means it intersects the circle in 2 points.
Yes.
That means the entire thing passes through the circle. And if it has one real root, that means it will touch the circle at
And-
only at one point.
and
So it will be a tangent.
Tangent. That's important. That's why I've written red color tangency condition.
Right.
Like tangent is a line which touches the circle.
Mm-hmm.
So it is a tangency condition. Now we're thinking how it is obtained. This one.
Right.
Just put d greater than 0 where d b square minus 4ac.
Okay.
On rearranging you will get this equation.
Right.
And d is less than 0,
Mm-hmm.
which means imaginary roots,
Right.
which means that r is less than root over mod c by root over 1 plus m square.
Okay. So
And
that
which-
means the line passes through. In fact, doesn't touch the circle at all. Or doesn't intersect. It just goes like above or below, or some side of it,
Yes.
and does not intersect the circumference at all.
Yes. So
Okay.
we covered this point. Now let us go into the tangents of the circle.
Right.
Like from here, like if there any circle equation is not mentioned, like all the equations correspond to the circle x square plus y square equals to r square.
Mm-hmm.
Now the slope form, the tangents can be written in different forms. So in slope form, it is given by the formula y equals to mx plus or minus r root of 1 plus m square.
Right.
This is the formula.
Okay.
And this is the slope of the line. Now in the point form, it is given by the s1 equals to 0.
Right.
In any conic, later you will study that for any conic,
Okay.
for point x1 comma y1, the tangent equation is given in the point form by s1 equals to 0.
Right. And this is a very significant result because it is a result for all conic sections in general.
Yes. So in the circle, the s1 is defined as xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 equals to 0 plus c
Right.
equals to 0. But this is for the standard equation x square plus y square plus 2gx plus 2fy plus c equals to 0.
Right.
Because this equation can be used for all the circle equations, so we
Okay.
standardize in the normal standard equation of the circle.
So again, to tell you how to arrive at s1, you just substitute x square by xx1 and 2x by x plus x1.
Yes.
And that is how, in all of coordinate geometry in any conic sections, you will have the condition of a tangent.
and we'll calculate the s1 by that.
Right. And there are other such expressions, where you just do some substitutions and we get an expression that we use in other formulae to make our job simpler. Because if you keep on writing 4 terms in every equation, it will become very tedious and the beauty of coordinate geometry will be lost.
Yes. Now we will be thinking what is the normal. Normal is perpendicular to tangent, but very important condition is it circle any normal. If you take any normal, it will pass through the center of the circle. One of the important property.
Right.
Now pair of tangent. Like if you take any point, a maximum of 2 tangents can be drawn. So how? If this is the circle, then if the point is outside the circle, then 2 tangents can be drawn like in this way. If it is on the circle, 1 tangent. Inside the circle, no tangents can be drawn.
Right.
And since we know the s1 equals to the here we have written here s11 we have studied above, the pair of equation of the pair of the tangent from that point
Okay.
x1 comma y1 is given by the equation s1 square equals to s into s11,
Right.
and the length of the tangent from that point, this length is given by root over s11.
Okay.
One of the important formula again. Now the director circle, like we know that in different lines, when 2 lines are perpendicular, they are a unique case. So we're gonna study what if we keep a separate name when the 2 tangents are perpendicular. So the locus of the point of intersection of perpendicular tangents to a given circle was found out to be a circle. So
Right.
we gave it a special name known as the director circle.
Okay.
And for a given circle x square plus y square equals to a square, the director circle equation is given by x square plus y square equals to 2a square.
Right.
And to be precise, for any circle if you want to define, it is a circle's equation with the same center of the given circle,
Right.
but its radius is root 2 times the given circle's
Exactly.
radius.
So when you square that, it becomes 2a square.
Yes.
And this is again, director circle is a very common concept, which on
use
which
in
problems are based in JEE and other entrance examinations. And you would be left wondering about what to do with this problem unless you're familiar with this concept.
Yes, you might be thinking what is director circle, what is director, and all.
Exactly, and sometimes you won't even have a hint of the fact that a concept like this has been discussed unless you are familiar in working with equations like this. Okay, so let's continue.
Like the chord of contact, when we are drawing the 2 tangents from here, S1, they cut the circle at 2 points. So line joining the 2 points is known as the chord of contact, and its equation is also given by S1 equals to 0.
Right.
There is a chord which is bisected at a point x1 comma y1. If you want to find the equation of that chord, then it is given by the equation S1 equals to S11. We know what is S1 and what is S11, so we will directly substitute there and we will calculate the equation of the chord. Now we can note here that the S11 will be less than 0 because the point is inside the circle. So we'll get that. Now pole and polar. Now actually we have not defined here what is the pole and polar. So what actually the pole and polar means, like if in a given circle we take a point and outside the circle, then we can draw infinite secants. So let us consider one secant. We draw the endpoints, tangents at the endpoints of the secants. They intersect at a point. Similarly, all the secants will keep on drawing the tangents and will note the points of the point of intersection of the tangents. Then the locus of the curve joining all these points of intersection of the tangent is a line in which is nothing but is known as the polar of a point x1 y1. And the equation is given by s1 equals to 0 for a circle s equals to 0. So here very important thing is if it is x1 comma y1, an infinite sequence can be drawn, and for all the tangent which can be drawn at the endpoint of the sequence, they intersect at this line, and the point is known as the pole and the line is known as the polar. Now let us study what are the conjugate points. 2 points, if we take a x1 comma y1 and b x2 comma y2, with respect to given circle they can be said as a conjugate point if the a x1 comma y1 lies on the polar of the b and the b lies on the polar of the x. So for example, if we take a circle like this, 2 points a and b, its polar will be somewhat like this. So if it passes, so actually now we are not drawn correctly. Like if it's polar, it should be passing to this point, its polar should be passing to this point. Then only those 2 points should be called as conjugate points, and those 2 lines are known as the conjugate lines. And the condition for 2 points to be conjugate is s12 equals to 0. Now you might be thinking, what is s12 equals 0? In s11 equals to 0, we knew that s11 equals to x1 square plus y1 square plus 2gx1 plus 2f y1 plus c equals to 0. But what will in that case replace x by x1? But in x1, if you remember what we did in s1, we replaced x by x, 2x by x plus x1 in s1 equals to 0, and x square by x into x1. In x12 equals to 0, we replace x square by x1 x2 and 2x by x1 plus x2, and similarly for y. So it will be converted of the form x1 x2 plus y1 by 2 plus g into x1 plus x2 plus f into y1 plus y2 plus c equals to 0. So the condition for 2 points to be conjugate is s12 equals to 0. Now in the second part, we will mostly study the properties relating to circles. So let us take equations of 2 circles whose centers are h1 comma k1 and h2 comma k2.
Okay.
And the radius are a1 and a2.
Right.
So the equation will be h minus k1 whole square plus y minus k1 whole square equals to a1 square similarly.
Okay.
So now depending on the cases of their intersections, we can say the number of tangents which can be drawn.
Okay.
So let us take this case 1, where c1 c2 is greater than a1 plus a2,
Right.
which means that this case, which means they do not intersect at all. Then the 4 tangents can be drawn. This is 1, this is 2, this is 3, and this is 4. And these 2 tangents are known as the direct common tangents, and these are known as the transverse common tangents, like which and between the 2 centers are known as the transverse common tangents. And the another point is the point of intersection of the direct common tangents and the transverse common tangents always lies on the line joining c1 and c2.
Right.
And there is specific condition that they divide the c1 c2 divide the points internally and externally in the ratio a1 is to a2.
Right.
Like if t1 is a point of intersection of the transverse common tangents and t2 is a point of intersection of the direct common tangents, then c1 t2 by c2 a1 equals to a1 by a2 c2 t2 externally, and c1 t1 by c2 t1 equals to a1 a2 divides in the ratio a1 is to a2
Okay.
internally.
Right.
Now the second case, with the distance between the center c1 c2 equals to sum of the radii a1 plus a2.
Okay.
Then what is the case is, then there are 2 possible direct common tangents and 1 possible transverse common tangents.
Okay.
Here. So this case covered. Next case, when the circles intersect each other at 2 different points, then what happens is only 2 direct common tangents are possible, no transverse common tangent is possible.
Right.
And when circle touch internally, then only 1 tangent is possible, which is direct common tangent. And when the circles do not intersect, like one circle lies entirely inside another circle,
Okay.
then no tangents are possible. No common tangents are possible. So
Right.
in all the cases, these 2, 1, 3 are common tangents.
Okay. And I'd like to remind everybody that DCT stands for direct common tangents and
Yes.
TCT stands for transverse common tangents.
Yes.
Okay.
And the length of the DCT or the TCT is constant for 2 given circles, 2 fixed circles. And if the distance between the centers is d and the radius are r1 r2 since we have defined above, the length of DCT is given by root over d square minus r1 minus r2 whole square,
Right.
and TCT is root over d square minus r1 plus r2 whole square.
Okay.
So if you want to derive, we'll just show how. Like this is a common tangent.
Mhm.
These are the r2 r1 perpendiculars drop.
Right.
We'll just zoom it, like it will be like this.
Mhm.
Circle, circle, r1, r2.
Okay.
This is d. We'll just drop a perpendicular from here on that.
Right.
So this is the length of the DCT and this is parallel to it. So this is also DCT.
Okay.
We'll apply the Pythagoras theorem here in this triangle and calculate.
Right.
Similarly for TCT, we'll do the same thing.
Okay.
Now, when for 2 given circles, we want to calculate the equation of the common chord.
Okay.
Then we just subtract the equation of these 2 circles.
Right.
So, if S1 and S2 are the equation of 2 circles, then S1 minus S2 equals to 0 gives rise to the equation of the common chord.
Right. By subtracting, we are actually just doing S1 equal to S2. So we are by finding a line, or actually points where which satisfy both S1 and S2.
Yes.
Okay.
Now, when 2 circles intersect, then we can define the angle of intersection of 2 circles.
Right.
Like actually, it is defined as the angle between the tangents or normals at the point of intersection.
Okay.
Like if they intersect, then at these 2 points the tangents are drawn, and the angle between them is calculated, which is defined as the angle of intersection of 2 circles.
Yeah.
And if the angle is theta, then cos theta equals to r1 square plus r2 square minus d square
Okay.
with 2 r1 r2.
Right.
And r1 and r2 are the radius of the 2 circles, and d is the distance between the circle.
Okay.
The proof is not so necessary, and you can easily do it. Just take the center C1, C2,
Okay.
draw the tangents,
Right.
and again draw a right angle triangle,
Uh-huh.
and we can easily prove it. You can usually most probably studying in your school only.
Okay.
So, and if for 2 circles to be orthogonal to each other, the condition is if the 2 circles are taking the standard form. Let's say
Okay.
x square plus y square plus 2gx plus 2fy, that one.
Mhm.
And 2 into g1 plus g2 plus f1 plus f2 equals to c1 plus c2.
Right.
This is the important condition for 2 circles to be orthogonal.
Okay.
And an important thing, like from here we usually we talk about the new terms which you have never heard before, like
Right.
the radical axis.
Okay.
You might be thinking, what is radical axis? Radical axis is nothing. Sorry, it's not nothing. It's actually a line. Like the radical axis of 2 circles is a locus of points from which the length of tangent to 2 circles are equal, and its equation is also given by the subtraction of 2 circles.
Right.
Like the radical axis can either be the common chord when they are intersecting. When they are not intersecting, it is a line
Hmm.
which is not intersecting the 2 circles.
Right.
Like when 2 circles are intersecting, this is the radical axis, the common chord. When the 2 not intersecting, this is the radical axis.
Okay.
Now we introduce a new term known as a family of circles.
Okay.
What exactly the family of circles means? Like we can define some certain circles to be a family when they have a specific condition, when they satisfy specific conditions.
Right.
For example, if you take a line, circle and a line, and we want to find the equation of all the circles passing to the point of intersection of the circle, like there will be infinite circles passing the 2 points, right?
Okay.
So it is given by the, if s equals to 0 is the equation of circle and l equals to 0 is the equation of the line, then s plus lambda l equals to 0 gives all the possible circles passing through those 2 points.
Right.
And similarly, if we are taking 2 circles, s1 and s2 equals to 0,
Okay.
then all the equation of all the circles passing through the point of intersection of these 2 circles,
Mhm.
s1 equals to 0 and s2 equals to 0, is given by s1 plus lambda s2 equals to 0, where s1 and s2 are the equation of the 2 circles.
Right.
Now, some new terms like
Actually, yeah, I'd like to interrupt that there, and I'd like to explain why S1 plus lambda S2 or S plus lambda L actually works. If you have 2 terms and you have 2 terms representing equations, and then you have 0 on the right hand side, then that will only be satisfied if a point satisfies both the curves.
yes,
Okay, so that is why when you write an equation of this form, you're indirectly saying that this point can satisfy both these things, and you include a lambda because that second circle can be variable.
yes.
Okay.
Now another important thing is, Like the line joining the two centers is always perpendicular to the radical axis.
Right.
Like, you know why? Like if we take the two circles, if it is a common chord, we know that the common chord is perpendicular to the line joining the two centers. So we know that. So from like this only you can understand that the radical axis is perpendicular to the line joining the two centers. Now we'll talk some interesting points known as the limiting points. Like the limiting points of a coaxial system are nothing but the members of the system with zero radius. Like if we have a radical axis, it is a radical axis for a family of circles, like certain circles like this. So these are the circles, for example. Then all these circles will actually be in the form. So what we'll do is, like from here, like the length of the tangent from the radical axis to the all the family of circles is equal. So there will be one circle from the distance from the radical axis will be equal to the length of the tangent, which means that circle has to be there. But it is also the center of the circle, which means that the limiting points are the circles, members of this coaxial system, indirectly the circles with zero radius. Means zero radius means actually they are the points, and they are of the form x square plus y square plus 2gx plus c equals to 0 when the x-axis is the radical axis. So this is the important thing we should remember. Like similarly, you can also derive if the radical axis is a y-axis. Like then we'll get of the form x square plus y square plus 2fy plus some d equals to 0. Like here, another thing we might remember is here the zero radius. The family of circles are given by this form, and the zero radius corresponds to limiting points. Now the radius is given by root of g square plus f square minus c equals to 0. So if we substitute the radius equation here, then we'll get the radius as r equals to root of g square minus c. So in order for the circles to be existent, the g square should be greater than c. Next, very important, and we'll be using this in the questions also. Like the equation of the circle, which is orthogonal to three given circles, is it is a circle which is nothing but whose center is the radical center of those three circles, and the length of the tangent from the radical center to any of the circle. Means you might be thinking now we skip the point radical center. What actually the radical center is? Like when there are three circles. So for example, here we are drawing there are three circles like this. Like then there will be three radical axes, each corresponding to two circles. Like this is one of the radical axis. This is one of the radical axis. This is one of the radical axis. The point of intersection of these three radical axes refers to the radical center. So this is the radical center. So again, three circles, radical axis, point of intersection of these three radical axes known as the radical center. We just skip the point. So just note that it is also very important. The radical center is the point of intersection of the radical axis of the three circles. So the equation of the circle, we have to, if we want to find the equation of the circle, it's orthogonal to the three given circles. So its center is nothing but the radical center, and the radius of the circle, and the radius of that circle is nothing but the length of the tangent from radical center to the end of the circle, because we know that the radical center is lying on all the three radical axes, but we know that any point on the radical axis has the length of the tangent equal to all the circles.
Right, because that is how we define the radical axis.
So it will be the orthogonal, so it will be equidistant from all that points, and it will be cutting orthogonal to all the points. This is just defined, and we have to remember that. So here we stop the theory of the circles. So from here we'll proceed on to the problems of the circles, and the questions will be you have to remember the formulas, and you can be easily able to do it.